What's up, everybody, and welcome back to another math puzzle. In this one, the question is as follows. 4 squares are shown below. Find the area of the red square. Which one is the red square? That is this guy right here. Hit that pause button and see if you can figure it out. When you're ready, hit play, and I'll give you the explanation. All right, so now we've said that there are 4 squares, meaning that this is a square, this is a square, this is a square, and the red square, which we're trying to figure out, is also a square. Okay, so let's start off with the basics. If I know the area here is 100 and I know the area here is 25, I can find the corresponding side lengths, meaning I know that this has to be 10 by 10, and I also know that this one has to be 5 by 5, okay? So that's the first thing. Now, the key is, since I know that this is a square, if I can just find a side length somehow, then I know if I square that side length, I'm going to be good to go. Okay, so the side length that I'm going to focus on right here for this puzzle is going to be this side length right here, because it's sort of in the mix within all this stuff, and I think it's going to be the easiest to decipher. Now, another thing that we can note is, since these are all squares, these are all right angles. And the reason why I am filling in those 2 right angles in particular is because these triangles are going to be very important. Now, what we may remember from geometry, and you may also just figure this out by looking at it and deducing this, but from geometry, we know that this line and this line, they're both going to be parallel, right? Because this is a square, and those are going to be 90-degree angles, 90-degree angles, going to make parallel lines. Now, why is that important? That's important because we know that alternate interior angles are going to be congruent when you have a transversal, meaning a line cutting through those 2 parallel lines. Why is that important? That's important because we now have angle-angle similarity, meaning this triangle is similar or proportionate to this triangle. Okay, now what we can start to do with this triangle right here is fill out some of the values. For example, since I know that this side down here is 10, I know that this side up here is also going to be 10. Since I know that this side here is 5, this would be 5 as well, this would be 5 as well, meaning this measure right here is 5 as well. Using Pythagorean's theorem, I can find this length, the hypotenuse, by taking 5 squared plus 10 squared, meaning squaring both of the legs, adding them together, and that's going to equal the hypotenuse squared. So that's 25 plus 100, which is 125, equals c squared. And c, therefore, is the square root of that, right? Taking the square root of both sides, we get the value of c. Square root of 125 can be simplified to 5 rad 5. Why is that? Because 125 is 25 times 5. The square root of 25 is, of course, 5. Okay, now that I have this triangle fully fleshed out, we can use that for this triangle, and the key side that we want to determine is this side, because that's going to be one of the edges of the square that we're trying to find the area of that square. Now, while I don't know this length and I don't know this length, I do know this length, the hypotenuse of this top right triangle, because it's this full length down here. It's the same thing, which is 15. So what can I do with this? Since I know that these 2 triangles are similar, I can set up a proportion. Okay, so check this out, right? I can say that, and we'll do hypotenuse to leg, okay? So I know that the hypotenuse of this big triangle is 15, and the leg that we're trying to figure out in green here, I'm gonna call that x, okay? So we're gonna say hypotenuse to leg is 15 over x. Now let's do the exact same ratio with this triangle right here. My hypotenuse is 5 rad 5, and then the corresponding leg that we're using that matches up with this leg right here is going to be the longer leg, which is this bottom leg here, which is 10. Now I have a beautiful proportion which I can use to solve for x right here. So let's cross multiply and solve. So we have 5 rad 5 times x equals 10 times 15, which is 150. Now to isolate, we're going to divide both sides by 5 rad 5. 150 divided by 5 is 30. So we're ending up with 30 over rad 5. Now I can, you know what, I'll rationalize the denominator because that's kind of standard in math classes. We don't really need to, but let's go ahead and do that. So to do that, we multiply the numerator and the denominator by that same radical, rad 5. Rad 5 times itself is just 5, because it's really the square root of 25, which is of course 5. And then on the top we get 30 rad 5. 30 over 5 reduces to 6. Okay, so now we're left with 6 rad 5 for this side length, all the side lengths. Now we just have to take that and square it. Why? Because side length times side length for a square gives us the area of that square. So let's do it down here where we have a little bit more room. What is 6 rad 5 squared? Well, that means we square the 6, which is 36, and we square the radical of 5. Squaring any radical or any square root will just give us the number itself. So 5, and last but not least, 5 times 36 is 150 plus 30, which is 180 feet squared for the win. Boom, done. I hope you guys enjoyed this math puzzle, and if you did, please click that like button. If you want to see more math puzzles on the regular, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.